Hey guys, welcome back to my channel. In today's class, we are going to study about the Fourier transfer, nuclear magnetic resonance. In the previous class, we have completed all the syllabus of NMR spectroscopy. Today is the last topic of NMR spectroscopy. Hope you are understanding and enjoying my videos. But I'm not enjoying. It's very difficult to make the notes. Guys, please subscribe and like my videos to just motivate me. And we will start with the today's topic. Fourier transfer, nuclear magnetic resonance. What is the first understand what is a Fourier transfer? Fourier transfer in the NMR spectroscopy, it converts complex waves into simple waves. It is a mathematical operation in which complex waves form can be broken down into simpler mathematical operations. This is the main function. This is the main purpose of the Fourier transfer nuclear magnetic resonance. Okay, see, it converts complex waveforms into simple mathematical operations. That's the main purpose, complex to simple. Okay, see, it is a mathematical operation required to convert a time domain spectrum to frequency domain spectrum, okay, or vice versa. See here what the Fourier transfer it is doing, right? Mainly it's converting the time domain spectrum to frequency domain spectrum. We will understand what is the both time domain and frequency domain. See, you are seeing the diagram. The frequency domain spectrum can be obtained by Fourier transfer employing a digital computer. See, frequency domain is uh, produced by Fourier transfer using a digital computer. See, time domain is nothing but a raw data of NMR spectroscopy. Raw data means it gives everything, every single peak. It gives every single peak. Okay, and process data means the FT-NMR, the Fourier transfer. It will analyze the raw data or the time domain and gives the wanted readings in the computer. This is the process data. It is called Fourier transfer data or frequency domain. Okay, this is the main purpose, and this way it works. It converts the frequency domain. Converts time domain to frequency domain. Here, see, complex spectrum is converted to simpler spectrum. Okay, by this we will analyze the sample. We will go through with the diagram. I have not drawn the diagram because it's very simple. You just see, you are maybe seeing the diagram. It contains, see, at the left side is there are south and north are the magnets. These are the very strong magnets which generate the field, and downside we see RF transmitter. RF transmitter, what's the main function of RF transmitter is it sends the radio waves into the sample. Okay, the main function is RF transmitter. Main function is it sends the radio waves to the sample, and it is controlled by the radio waves. It is controlled by you can see frequency synthesizer. The radio waves is controlled by frequency synthesizer, and it is sent by radio frequency transmitter. And the pulse switch, you are seeing, right? Between the both of them, pulse switch controls the time and duration of radio frequency with the sample, and uh, it ensures that it is accurate and reproducible data. It is producing reproducible data. That's the main function of the pulse switch. And phase sensitive detector, it detects the readings after radio frequency amplifier. It sends into the phase sensitive detector where it amplifies, and this complex, here we have an time domain data, okay, complex or raw data, which is sent into the time sweep computer and Fourier transfer, where it is converted into processed data or frequency domain. Okay, by this frequency domain we can understand the compound. Okay, I hope you understood the diagram. The parts are quite similar, but here we don't use the magnetic sweep. Instead of magnetic sweep, we use radio frequency transmitter, where it itself sends the radio waves to stimulate the sample or to excite the sample, and the coil receives the readings from the sample. Okay, and you can write the parts on your own. Okay, I'll just tell you the main parts. The radio frequency coil produces a short powerful pulse of radio waves. Powerful magnet, I already said, produces strong magnetic field. Magnet and probe are similar to those of continuous waves. Okay, next, sample is placed in a glass tube that spins so the test material is subjected to uniform magnetic field. We already studied in the normal NMR instrumentation. Next, radio frequency coil that detects the radio frequency emitted as the nucleus relaxes to a lower energy state. After the energy is applied, it receives the energy and goes to excited state, and it comes back to normal state. The normal state, or when it comes back to normal state, it releases the energy. This energy is collected by received by radio frequency coil. Okay, next, a computer that analyzes and records the data. That's the main points of the Fourier transfer instrument. Just understand the concept and how it is helpful. That's it. Muchly morely they will ask the diagram and what's the process behind. You have to write the process, that you have to explain the diagram. That's it. Okay, next, what are the advantages of Fourier transfer NMR spectroscopy? Increases the sensitivity of NMR measurement. As we have studied, it increases the sensitivity. It detects more compounds than the normal NMR. Okay, has widespread applications like C13 NMR, 31P NMR, 19F NMR, gives high signals to noise ratio, facilitating rapid scanning. Here it has wide application in these compounds and has a rapid scanning. Okay, can be obtained with less than 5 mg of the compound, and see, as the sample, if it is present in less quantity also, it doesn't matter, it can analyze it very easily. The signal stand out clearly with almost no electrical background noise. See, no electrical background noise means no different signals that intercept with the standard signals. Okay, MRI is most prominent FT-NMR application. See, MRI you see in the hospitals, right? MRI, it's the FT-NMR prone application. Okay, where this application is used in the MRI. Okay, these are the basic advantages and the instrumentation and the theory of the FT-NMR. Okay, next, the we will discuss about the 13C NMR or carbon. C means carbon, 13 carbon NMR. Okay, nuclear magnetic resonance concerns the magnetic properties of certain atomic nuclei. It concerns the atom having spin quantum number. Okay, 12C nucleus is not magnetically active. The spin quantum I equals to 0. From our previous videos, we understood that only integers are spin active. Okay, odd numbers are spin active, even numbers are not active, like 2, 4, 6, 8, 10, 12, 14, so on. They are not active because they are even numbers. Only odd numbers are active. But 13C I equals to 1 by 2. Okay, it is active and it has many advantages over 1H or hydrogen NMR. Okay, we will go through that also. The gyro-magnetic ratio of 13C is 1 by 4 of that of H. It is a ratio which is 1 by 4 than of that of H. Each non-equivalent C13 carbon gives a different signal. A 13C signal is split by the H1 bonded to according to the N1 plus rule. See here the 13C signal is split by hydrogen according to the N1 plus rule. We'll understand what is the principle of it. These are just the points. We understand what is the principle. When the energy in the form of radio frequency is applied, when applied radio frequency equals to the gravitational frequency, when we know that there are two frequencies, first frequency and second frequency. If the second frequency is similar with the first frequency, then absorption of energy occurs in nuclear in resonance NMR signal is recorded. Okay, this is recorded, and the you see the advantages of C13C NMR over H1 NMR. 13C provides information about the backbone of nucleus rather than the peripher. It's telling that the C13 carbon gives an in detail information rather than the top क्या बोलते हैं ऊपर ऊपर का information rather than it gives a complete information. Okay, rather than giving some information. Okay, that's the meaning of this line. The chemical shift ranges from range for 13C NMR for most organic compounds is 200 parts per million compared to 10 to 15 parts per million of hydrogen. See, the chemical shift is also very high for 13C NMR, and there are a number of excellent methods for decoupling the interaction between 13C and H. Here decoupling is used to, what is decoupling? Just tell me in the comments if you have understood the previous videos. Decoupling reduces the complexity of the NMR spectrum. Okay, it simplifies and it prevents the spin-spin coupling. It is called decoupling, and there are a number of methods that can decrease the spin-spin coupling between these two atoms. Heteronuclear spin coupling between C13 carbon and 12C carbon does not occur because spin quantum number of C13 is 0. Okay, sorry, it's 12. Because spin quantum number of C12 is 0. See here, this C12 carbon does not have any spin and C13 has the spin. Okay, so that their nucleus does not collide and coupling does not occur between these two atoms. That's the main advantages of over hydrogen NMR. Then it has many advantages of 13 carbon. Next, we will discuss the applications of NMR spectroscopy. There are many applications. You will see structure elucidation. There is nothing to explain. You just write down the points and write in your exam. Investigation of dynamic properties of the molecule, and these are the dynamic properties like conformational, restricted, rotation, molecular bonding, hydrogen bonding. Okay, keto, enol, tautomerism, determination of the optical purity and the molecular interactions. Quantitative analysis, it determines the biomolecules in aqueous solutions. NMR is used for food science, and it is helpful in spectroscopic techniques of organic chemistry. In organic chemistry, it determines the chemical properties of functional groups. Okay, these are many applications. By this you will complete 2 units, UV spectroscopies, and first unit and second unit. In next class we will start with the mass spectroscopy. Guys, if I'm not that much good in these making the videos, but I will learn over time, and I hope my English is an understanding. You maybe you are understanding it, you're getting my points, right? If not, just comment me, then I will just improve my videos and my lectures. I just want to provide notes and make it easier for you guys. That's it. Thank you guys. Bye. Good night for today. It's, if you're seeing it night, if you're seeing in morning, it's good morning, guys. Okay guys, bye. See you on the next chapter, mass spectroscopy. Bye.